Okay, I'm gonna write some code today for a idea that's actually really important in physics, but it's a purely mathematical idea. It uses random numbers, which we've done before recently. I'm gonna code it using a method, which we did, I guess, last block of the class last week. And it's called the one-dimensional random walk. And the thing to imagine is really simple. Imagine you're standing on a long sidewalk and you flip a coin. And if the coin comes up heads, you take a step to the left. And if the coin comes up tails, you take a step to the right. And you just keep doing that. And the question is, over time, what is most likely to happen? Are you likely to stay where you started? Are you likely to drift off in one direction? Are you likely to drift off in another direction? And quantitatively, even though it's random, is there something that can be said that's predictable if you do it many times? So that's what we're going to do. I'm going to code just a random walk that happens some number of n times. You flip the coin n times, and where do you wind up? How far from where you started? So we'll call the point where you started 0. You take a step to the left, go in the negative direction, like a number line. Take a step to the right, you go in the positive direction. So we're going to code a method, and we're going to call that method random walk. We're going to have it be, I'll just do this by hand. Let's see. So I've imported the scanner in case we need to read the n in from the user. I might just code it in by hand for now. And we imported our random library, so we can use the random class to generate random numbers. So I'm going to need a public class, static, and I'm going to have it return an integer. The return type of the class is going to be an integer. I'm going to give it an n, flip the coin 1,000 times, and then it's going to return where I wind up, what point I wind up. And since I'm just going left and right by 1, that number is going to be an integer. How many steps did I take, either left or right? So that's the return type. I need a name for my method. I'm going to call it random walk. And it's going to accept some kind of argument. I'm going to give it some parameter. That parameter is going to be the number of times to flip the coin. So we're going to call that, what are we going to call that? Let's call that little n. And that's not what I have in my sample code, but because I want big N to mean something else. Okay, so int n. N is going to be how many times to flip the coin. And then I can start my method. I'll do the thing that I like to do, which is to mark the end bracket. So if my method gets longer than a screen, I can tell where I am. So this is end of random walk method. Okay, now I can write my code in here. The first thing I'm going to need to do, remember, if you're using the random class, you have to create an object of that class called random, or called whatever you want, but I'm going to call it random. And that's a new instance of the random class. This is just what you need to do to use the random methods. And I'm going to start my position at 0. So x is my position. That should be int. My current position is x. And we start at 0 on the number line. Okay. Now we're going to have a loop. And we're going to flip the coin n number of times. So we'll call each of those iterations a step. I'm either going to step to the left or I'm going to step to the right. So for int step equals 1, we'll start at step 1. We'll go up to n, so that step is less than or equal to n, and then we'll make step 1 bigger each time. Okay, so this is my for loop. I'll go ahead and type the close bracket right away. And then we'll put my content in the for loop. What am I going to do in my for loop? I'm going to flip a coin. How do I flip a coin in Java? I'm going to create a variable called flip. It's just going to be an integer. That integer is going to be 0 or 1. Those are my two choices. So I want to generate a random number with just two choices. So that's going to be the random class and the method called nextInt. And this is all stuff we did in our dice programs. And then we give it a parameter, which is the range of the random numbers, and we're going to have 2. So nextInt2 is going to give me a random number from 0 to non-inclusive. So it doesn't include the 2. So it's just going to be either 0 or 1. And we'll double check that a little bit later to make sure that's working properly. So I'm going to call that flip. The flip is either going to be 0 or the flip is going to be 1. If the flip is 0, if flip equals 0, then we'll make 0 a step to the left. So we'll make x 1 smaller. I don't think we've used this command yet. Just like we use x plus plus to make x 1 bigger, we can use x minus minus to make x 1 smaller. And conversely, if flip is equal to 1, why is it not working? 1, then x plus plus. Okay? So we imagine standing on a number line. I generate a random number. If that random number is 0, I take a step to the left and go more negative. If the number is 1, take a step to the right and go more positive. And that's it. Do we want to put a print statement in here to debug it? Not yet. We'll debug it in a second. Okay, that's all the function has to do. So that's the end of my for loop. It flips the coin n number of times, takes a step left or a step right, and then at the end I want to return from my function the final value of x. Where did I wind up? Okay, so before I leave my method, if I'm accidentally occasionally saying function instead of method, just in your head translate that to method. I've been recording Python videos at the same time, and it's hard to keep myself from falling back on the old Python vocabulary. So I'm going to return from my method the value of x to wherever the method was called. And that should be it. That should be my method. That should be all I need. Okay, a for loop goes up to n, flips a coin, gets a 0 or a 1. If it's 0, I step left. If it's 1, I step right. I'm going to just click run right now. Nothing should happen because I wrote my method and I didn't call it. Yeah, nothing happened. So the program doesn't do anything. The main program down here has got nothing in it. There's nothing in main. I just wanted to make sure there are no syntax errors, missing semicolons or whatever in my method. So I'm going to collapse it by clicking the little triangle here. So my random walk method is done. Now I need to call it and make something happen. Let's create an integer called n. Do I want to call it n? I don't like using the same variable for the global variable and the local variable that has the scope of just living in the method. So let's use a different variable for it. Let's call it, we'll just call it number of trials. A number of flips. Steps. Let's call it a number of steps. Okay. Do we want to use, that looks ugly, let's use underscores in there. Okay. Number of steps. I like that. Okay. How many times do we want to flip the coin? And we're going to start, I don't know, just pick a big number like 100. Okay. So we're going to take 100 steps. Now we're going to call our method and assign the result to a variable. Let's call it result. Result is equal to what? It's equal to the number we get back when we call our random walk method, giving it number of steps. So if number of steps is 100, we give that number 100 to our random walk method. It computes the random walk and it gives that x back and stores it in the variable result. And then we just need to print out the result. So let's see. Well, I'm copying over here, so I don't have to paste. System out print line after number of steps as our variable. So after number of steps plus quote steps, comma, the final position is space end quote plus and then result, which is the number we got back from our method. After number of steps, the final position is result. I think that should work. Let's run it. See if it works. Did I forget a semicolon there? Nope. Look at that. After 100 steps, the final position is 24. Let's run it again. After 100 steps, the final position is 0. It went left just as many times as it went right. After 100 steps, the final position is -6. The final position is -8. The final position is -18. The final position is 14. The final position is -2. The final position is 12. So it seems to be working. How can I be sure that the right things are going on behind the scenes in my method? Let's do a couple of things to test it. A couple of things I just want to be confident of. Let's open my method up again. After I do the flips, let me just print the flip, just to make sure I'm only getting 0s and 1s, just to make sure that I used this next int method of the random class correctly. Okay, so let's just do that. So these are my flips, 1 0 0 0 0. So that's working right. Okay. The other thing I want to do is to just print out the x's as we go. So I'm going to delete that. I know that's working now. I mean, I could leave it in. What should I do? Let's leave it in. Let's leave it in and comment it out. Debugging print statement to check flips. Okay. What's good practice for this? I mean, what do I do? When I put in little print statements like this to debug stuff, I usually comment them out. And I comment them out until the whole program is working and it's done. And when it's done, I might go back and take them out again. That's the best practice, I think. Let's do the same thing with x. Let's print out the x's as we go. So system out print x, and we'll do print line, so they're on separate lines. And again, I just want to watch my x's. I just want to see the program run. Make sure it always starts at 0. Let's scroll up. So it starts. Well, it doesn't print the first step, but the first step is 0, right? It only prints after the first flip. -1, -2, -1, 0, 1, 2, 3, 4, 4 pluses in a row, and then 3, 2, 1, 3 negatives in a row, and then 2, 3, 2, 1, and then back to 0 again. And then we start to fall towards the left. -1, 2, 3, 4, 3, 4, 5, 4, 5, 4, 3. So they're only changing by 1, and they seem to be just as often going left and right. So I just wanted to see that happen to make sure I'm confident in my program. So that is a one-dimensional random walk. If I made this number bigger, if I had 1,000 steps, did I comment out those print statements? Oh gosh, let's do that. Sorry, I meant to do that before I went out. So let's comment out this print statement and write debugging print statement to check the values of x. And we'll comment that out so it doesn't actually execute, so it'll just give me the answer. After 1,000 steps, the final position is -10. After 1,000 steps, the final position is 36. After 1,000 steps, the final position is 44. After 1,000 steps, the final position is negative 36. Okay, so this is working. This is doing what I want. Why is the random walk important in physics? It's important in physics because when you're thinking about the motions of atoms and molecules, you can think about them as moving about randomly. When you think about what happens when you open a container of gas, if the molecules are all moving about randomly, how do they move away and diffuse out into a room, for example? You can think of the motions of those atoms and molecules in terms of a random walk. Now, that would be a three-dimensional random walk, which would mean instead of just having a coin flip for left and right, you'd have a coin flip for up and down and a coin flip for back and forth. We could do a three-dimensional version of this program as well. And that's kind of what, in statistical thermodynamics, we treat atoms and molecules as if they're undergoing a three-dimensional random walk in space. And this is the question that I want to put out there to you. If we did this a bunch of times, and took this random walk and put it inside of a loop, like I'm doing just by clicking run over and over again, I know you can't see me anymore, I get negative 40, I get 2, I get 2 again, that's crazy, negative 14, negative 10. If I, instead of clicking over and over again, put this random walk in a loop and did the random walk hundreds, thousands, hundreds of thousands, millions of times, on average, what happens to the molecule or the person flipping the coin? On average, do you wind up close to zero? On average, do you wind up gradually drifting away from zero? How does it work? So if I ask you to do an extension of this program, what I'll ask you to do is to take this part of the program where we call the random walk right here and put it inside of a loop and do it a bunch of times and keep track of the result. What is the average result? And can you draw any conclusions from that? So that's what I'll do. The other reason this is important is it's because it's really related to things like gambling. If you have a game where you just flip a coin and you do it a bunch of times, are you more likely to win or to lose? Well, if the coin is a fair coin and the chances are 50-50, you're just as likely to win as you are to lose. And if you flip it 1,000,000 times, you're more likely to win each flip. Sorry, you're equally likely to win each flip as you are to lose each flip. What if the odds are a little bit off? What if you've got a coin that wins 49% of the time but loses 51% of the time? What is most likely to happen over time? This is essentially how all the games in the casinos work. Every game in a casino, you are slightly more likely to lose it than you are to win it, which means over time, the probability that you walk out with a lot of money gets less and less and less and less. So the random walk is a way to kind of experimentally examine the results of randomness, the results of kind of fair games versus unfair games. What happens over time as the number of trials gets bigger and bigger and bigger. Okay, so I'm going to leave that. I'm going to leave it there. But I may ask you to do an extension of this as a programming problem or even a problem on a quiz or an exam.